We're starting an ipart for all these yellow. The part number is 00221111 and there are 31 configurations. We're going to start with the first one that's on page 7, the valve spring keeper pin, and it just has 2 diameters here. So whenever I did that, I typed in shaft underscore diameter equal 0.063 and that created my parameter for me. If I hover over this and I click on this, you'll see the parameter right here for that dimension. Alright, I'm going to hit E for extrude, and in extrusion, that's where I'm going to put the parameter for the length. Equal, and that is 0.24, and that's solid, and say OK. So right away I already have 2 parameters. So what I'm going to do now is I'm going to go to the next part. So if I go to the next one here, on page 8 I've got a rocker arm roller pin. The rocker arm roller pin has multiple features. It has a different diameter, has a different length, and then it has an undercut, an end chamfer, and a flange. So now we're going to go back to our part, and we're going to create this as an ipart. So I'm going to go to Manage, and I'm going to create an ipart. Now something I want to show you guys here is something under Options. Under Options, I'm going to set this to a value of a part number, and the part number is the root number, not the extension. So remember, the dash number is your configuration number. So see how it says part 1-001-02? This tells me how many digits to the right. So I can have 3 digits to the right. My separator is going to be a dash, and the initial value is going to be -001. Does that make sense to you guys? So now if I put my part number in here, we go back, what was that number? This one? Yes. I'm just going to take the root, and I'm going to put the root right here. So as you notice down here, it takes the root, it puts a separator in here, it starts at 1, and it has 3 digits. Does that make sense? Alright, and we're going to set the member name to the part number. Say OK. Yes. So now when I get over here, here's my member name, should be my part number, and I need to save this part, so that will give it that part number. That member name will be our base part number. Okay, so now I'm going to right click on this and I'm going to insert a row, and notice that the part number changed to, or the member number changed to the part number. I don't know why this one didn't change, but I can manually put that in. Okay, so we have those 2 parameters, and we're going to change those for the -2. The -2 length, if I go to my spreadsheet, this makes it pretty easy. I can copy and paste this in here. Sorry. Yes, but it has to be set up before you ever import it. Yeah, yeah. So I can show you guys that if you want me to in another time. On this one, the diameter we saw was 125. So you can either copy it and paste it, or you can just put it in manually and say OK. So now I have my table, I have -1, and I have -2. Alright, so now that I'm in -2, I'm going to create the other features that I'm going to be computing or suppressing in -1. Does that make sense? Okay, so from this one, I'm going to put a flange on here. I'm going to create a sketch on that face. and that diameter is 0.187. And I'm going to hit extrude. I'm going to select this one, and I'm going to put in here my flange length. Equals, and that is 0.025. Okay, now I'm going to name these. I'm going to name this shaft, and I'm going to name this one flange. We did that when we typed it into the dimension. The question was, do we need to put a label for the diameter of the flange? So the diameter of the flange, did I not do that in here? Very good, thank you. So if I double click on this, it says this is the descriptor, so no, I didn't do that. So I'm going to put in here flange diameter equal. Thank you. Finish that one. And so now, when I go back to my table, I'm going to add something to suppress or compute. And since I named these over here, it's going to be really easy for me to understand what I want over here. So in this one, I want this one to be suppressed in the first part and to compute in the second part. Does that make sense? Okay. Now if I go back to parameters, I'm going to come down here to the flange, and I'm going to add some other flange parameters. Alright, so now if I have the flange suppressed, does it even matter what these are? Alright, let's see what it does. Okay, so it doesn't matter about the parameters of the flange if you're not using the flange. Does that make sense? Okay. So the next thing that we said was that this one is the overall length with the undercut included and the end tip included, and it has a chamfer. So now I'm going to create an undercut on the shaft that I just created. And then I'm going to create an end chamfer and exclude or compute it or suppress it, and then I already have that in there. So in the undercut, I'm going to create a new feature, find a plane in the middle, create a sketch on it, and right here you can go to slice graphics and it'll show you the center. So now I'm going to revolve this cut. So we just learned this trick from Alberto. We just learned this trick from him. And I'm going to go ahead and project the geometry of the bottom plane because it's that where it's dimensioned from. Okay. And now I can take this and I can turn it to a center line. That was a really nice trick. Alright, the next thing I need to do is project geometry of the edge of the part so that my cut follows the diameter. So I'm going to put a rectangle in here, and I'm going to put in here the spacing. So I have a dimension for the height of this. That's not the one I wanted, is it? Delete. Dimension this one. That one's 18 thousandths. And I'm going to go to home and I'm going to put in here undercut. Width. Okay. Equal. Alright. And then the next thing I have is a diameter. So I'm going to put a dimension in here, and to get a diametric dimension, that's another thing that I'm going to be looking for in your sketches. I want to see diametric dimensions when they're called out on here. I don't want to see radial dimensions. So from here to the center line, doesn't matter if it's a point or a line, it gives you a diametric dimension. That one's 0.073. And if I go to home, this is going to be undercut, diameter. And now we just need the undercut location, right? So if I put a dimension on here, there are two ways that this is dimensioned. It's dimensioned from the bottom of the flange. So I can just put that dimension in there. What you want to look at is you want to make sure that all these that have this undercut are dimensioned in the same manner.
If you do that, then it's going to maintain, it won't change, the position won't change with the length.
Okay, so that's the insight here is that the position won't change with the length, so we have to do it from the other end. So I'm going to specify that in my parameter. Let's say location. Okay, from opposite the flange, and that's 30 thousandths. Alright, I'm going to hit R for revolve. I'm going to make sure that this is a cut. Say OK. Now I've got that in there, and I'm going to change this to undercut. Now the next thing that I need is a chamfer. We said that it was 15 thousandths times 45 degrees. So I'm going to go in here and put a chamfer in. Now when you do a face, it's trying to measure from what face you're going to measure that angle. So if it's 45 degrees, does it matter? So we can make this one a D times D. And we can make this one 30 thousandths. And I'm going to go to home, and I'm going to call this, bless you, chamfer opposite flange equal. I'm going to select my edge. And that was 15 thousandths, right? Say okay. So now,
Chamfer on the other end too. It's just very slight.
It is very slight. I don't even know what to put on the chamfer on the other end. Let's just leave that one as is. It may be a round even. Let's call this chamfer opposite flange. Okay, so now I have three features that I'm either going to suppress or compute. I'm going to go to the table, and now I'm going to bring those in. So suppression, undercut, chamfer. So I'm going to suppress them here, S, and S. Okay, now I need those dimensions from the undercut and the chamfer, right? So I'm going to go back to parameters, and I'm going to go down to that feature. I've got my undercut. Now I'm going to bring these in because I'm going to be using these for other configurations later. Same thing with the chamfer. They may all be the same, but I'm still going to put it in there. Alright, so since this is suppressed, we don't really care about these. It's not going to compute that. And I'll always just go back and forth and click between the two configurations. We're going to make another mock dash number. So what I'm going to do now is I'm going to create a hole. It's going to be concentric. And let's say I put it down here on this plane, concentric with this surface, and of course it's huge. So let's make this a threaded hole. And let's make this 256. Number 2, when it says 4, 446, 8, 10, 12, you're going to go down here to the numbers down here. Okay? Alright, let's say it's 256 and it is a distance. So in this distance, I'm going to put in here thread depth equal. And let's just make that, how long is that pin? The pin is only like 0.3, so let's make it 0.125. Alright, and it's 256, and it's concentric. So everything is good. The termination distance, you want full depth of thread on these holes, okay, on these taps. And what did I not get? The concentric reference, because it was so large, wouldn't even let me pick it. Let's say okay. Now we got the thread depth on this one, we got the thread on this one. So let's say that we're going to create another configuration. And these are going to be out of order for me. You're going to wait until you get to that point to make the -3. But anyway, we're going to go to suppression, and I need to name this. I'm just putting something in here so that we kind of understand how to do threads. So let's go back to the table and let's insert one of these. We're going to go to suppression. I'm either going to suppress or compute this. As I go there, I'm going to go to parameters. I go down to the blind tap tool, and I have the thread depth, and that is just the tip angle. So we're really not going to change the tip angle. No. That's for your drill tip, and then you're going to tap it, so it doesn't matter what that is. We can go to threads here, and I can take this one in to account, and I can say that this one is going to be 256. Do I want it to be right hand thread? Do I want it to be a class 2B or 2A? You can change all those things. So I'm going to go ahead and put those in, and let's stretch this out and look and see how it looks. Woo! Alright, so I have a 256 hole that's so deep, and I'm going to suppress it in these. I can't tell what this is doing. You can work with this in an Excel format. Alright, we've got those, and now we're going to create another. Let's go ahead and create another configuration. Let's say on that OK on that one, make sure that made. -3 now has the blind tapped hole. And let's go in here and let's say we're going to create a -4. And on this one, we might change the thread specification. Let's see if that'll work. Alright, so it just goes ahead and makes a 440 hole the same depth. If I needed it to be a different depth, then I would make it that way. So we're going to apply, we've gone to the first one, we applied high strength low alloy steel. And in this one, we're going to make this one stainless steel. So do that to me sometimes. .304 is a good standard stainless steel. Alright, and let's save this as part number. Then we go back to the table. Where did our material go? So I'm going to go back to properties and go to physical. I did? Dang it. I did? I gotcha. Alright, so we're going to go to properties, physical. We're going to bring out the material. And while we might, okay, let's see. So if I go to this one, how am I going to change it? it doing this to me? This is high strength low alloy steel. Let's go back to the table. Alright, now let's look at it. Nice. So you could save this for the very last and go in here and change your material properties every time. It's really cool.